So I see like only one person raised their hand. So that's a lot of coders, a lot of people who have coded before. Oh yes. So because the aim of this introduction was also to make it easy for everyone to understand, even beginners. And another thing I also want to show you, I shared these resources. So I created a Google Drive where I'm going to share my resources. So there's already one here. This is links. So here you're going to see links to resources like here, the Rise programming language docs and Stellar Dev docs. So you can see it here. And there's also a Rust cheat sheet that I got from zero to mastery. I don't know if you're familiar. So I just saw that this was a very good, they have like basically everything that you need to get started. It's only 68 pages. And another thing, if you're learning Rust, one thing that I can encourage you to do is to use artificial intelligence. Let's say you're using this, let's say you're reading this and you're trying to like, let me look for something here. I want to learn about variables. No, this is so simple. I want to learn about match, for example. Here you're going to read, okay, match provide exhaustive pattern matching. This allowed the compiler to ensure like blah, blah, blah. If you don't really understand, you can just copy this and then put code and then ask ChatGPT or your favorite AI to explain to you as if you are 10 years old or if you're a complete beginner. And you can also ask it to give you more example on how to use it and so on and so forth. You can even ask AI to give you questions. And you also try to answer those questions just to reinforce your learning. So I'll advise you to use AI. Don't use so much AI when it comes to building for now. Use it for learning, because if you depend on AI to build, like you just build using AI, you might get into like a huge code base and you don't even understand what's going on, and bugs, you don't even understand what's going on. So it's very good to know how to code, to know the fundamentals and all that. Okay, what is programming? For the total beginners, programming is like writing a recipe that a computer can follow exactly. Just like a cake recipe tells someone step by step how to bake, we write instructions, and that tells computers what to do. So this is what programming is. And there are different languages, like for example, there's Java, there's JavaScript, there is Python, and there's like thousands of, or maybe hundreds of different programming languages. And they're all, some of them are used for specific ways. Like for example, some programming languages are used for the backend of a program. Some programming languages are used for the front end. Like for example, we use JavaScript for the front end. We use CSS. I don't even know if we call CSS a programming language, but we also use there's also specific languages like SQL, where you can only use it for databases, for example. And yeah, so programming just acts like a recipe. You give it instructions like, okay, I want this application that I create to do this and that. For example, WhatsApp. You know what WhatsApp was created for communication. I send you a text message, you receive it. So all this was behind the scene. There was instructions. There's someone who wrote those codes to instruct what happens after every action. I hope that makes sense so far for the beginner. And so what is Rust? Rust is a language empowering everyone to build reliable and efficient software, especially perfect for handling money and financial applications safely. So Rust was created in a way, it was created for efficiency. And another thing about Rust, it forces you to write clean code because you get all these error messages, even for like small, simple mistakes that you will ignore in other programming languages. So it forces you to write very clean code. And if you a C programmer, if you program in C, I'll also suggest you learn how to code in Rust, because learning Rust as a C programmer will also teach you, will also make you a better C programmer. So these are the installation instructions. This is something I can do later. So to install Rust, you go, if you're using Mac or Linux, it's very simple. You just run this, or you can just go here and follow the instructions. Let me just show you. Oh, I should have opened a new page. But anyway, so this is where you install Rust. If you're using Linux, you use this. And I use Windows subsystem for Linux. So I think in the week I'm going to send some resources that will show you how to install it if you want to use Windows subsystem for Linux. It makes everything easier. Or you can just, for Windows, you install it here. And another thing that you need to install is the editor. So the editor is the application that you use to write code. So I use VS Code. I think VS Code is the best one. You can download it on code.visualstudio.com. And once you're there, also install Rust Analyzer extension. This will help you to highlight the code and also the errors. And yeah, once you have that in your system, you're good to go. But I'm going to send you some resources in the course of the week that will help you to install it. I don't want to go into it because it takes a lot of time. It might take like an hour just to set everything up. So let's assume we've installed everything, or even where you are, you can actually start playing around with Rust without even having to install something. There is what we call the playground, the Rust playground. I'm going to share the link of the Rust playground. As you can see, here is a simple code. It's a simple Rust code. That's just one thing, which is print hello world. I remember the first time I coded, I learned that a lot of devs their first program, it's always printing out hello world. I didn't want to do that. I did something different because I was like, why does it have to be hello world all the time? So you can type whatever you want. It doesn't have to be hello world. Let me just show you demo. I can say maybe Stella, and tap Stella here, and then run. And you're going to see the output at the bottom. And the top here just shows if there's any error. You're going to see you'll see errors here. So this is just a simple application. And the FN here, if you use Python before, you have function. So in Rust, the FN just stands for function. And the main is the start of the program. So when the compiler runs, it goes to main, and then it runs whatever is under main. So, okay, so that you can do at home. I'm gonna send you some resources. But here, let's talk more. So Rust Rust was specifically chosen by Stella because it's incredibly safe for handling money because we're dealing with money. And by the end of today, you write your first Rust program. So why Rust for blockchain? So a big problem. What happens if there's a bug in your software that handles millions of dollars? Traditional languages allow crashes that lose money. Uh, Memory errors can be exploited by hackers, and race condition can duplicate transactions. I think a lot of these things won't make sense, but as we go along, you will understand what is race condition. You'll understand all this memory error. But we like you've seen so far. I like repeating myself. Eventually, you're going to catch what it's all about. So, how does Rust solve this? So, Rust has memory safety. So Rust ownership system ensures programs use memory correctly, preventing crashes from errors like accessing invalid data. It's like a librarian ensuring you only touch the files, you only touch the right files. Sorry, somebody joining. And it also solves this by there's no null pointer differencing. A null pointer happens where a variable, you learn about variable for beginners. So a null pointer happens when a variable points to no data, and trying to use it can crash a program. Rust avoids this entirely by using the option type, which forces you to handle missing data explicitly. This ensures the compiler catches potential issues before the program runs, reducing unexpected crashes from missing values. So this is like one of the difference that Rust, when you compare it with other languages. So you have to make sure, so Rust makes sure that it forces you to handle any missing data explicitly. And another thing is concurrency safety. Rust prevents race conditions, errors when multiple tasks access the same data or access data simultaneously by enforcing strict rules on data sharing, ensuring tasks like web requests, for example, and other tasks don't clash. Another thing is performance. Rust runs as fast as C++ because it compiles to efficient code without a garbage collector. But it's safer due to its memory and concurrency rule, ideal for games and servers. So garbage collector, if you're familiar in coding, you probably know what is garbage collector. A lot of programming languages like Python and Java have like, I'll say like a garbage collector robot. So basically what happens is when you're writing your program, when your program runs, there are instances where some of the data are no longer used, or some of the variables are just, they are just bloating the program, because you're no longer using it. So to solve this problem, Java, for example, has a garbage collector robot that comes and cleans up all that from your memory, so that your program can work more efficiently. But at the same time, the action of cleaning itself, so sending that garbage collector robot to clean up all the data, all the data that is not used, can also slow down the system. And that can be a problem when you're trying to run some key program, or maybe some key things in your program. But Rust does not have that, and which makes it ideal for games or servers. Another thing is modern syntax. Rust here as a clear and concise syntax, like for example the hello world. It's easy to read and write, making coding less daunting for beginners. So now we're going to move on to writing your first program. If you have two screens, you can try it even now as I'm talking, or you can just put a split screen, one split screen for me and the other split screen for the Rust playground. So this is a simple program. It just does one simple thing, which is to print whatever I put here. So we try to understand each part. So there's fn main. So the fn is just function. This is the main function where our program starts, and then there's the print line. The print line prints the following text. So it prints the text that is in between this bracket and the double quote, the quotation marks. And when you're using your terminal, when you have installed everything to run your program, you run it by typing cargo run on your terminal, and your program is going to run, and it's going to print out Stella. Or in this case, you can change it to anything. You can change it to Hello Stella. You can change it to whatever you want to do. It's just simply going to print whatever I put here. So it's very much straightforward. This is just the simplest program you can write. Okay, now we're going to move on to understanding variables. So what are variables? So variable is like a label box. It's like a container where we store information. In blockchain, we store things like account balances, addresses, and transactions amount. In Rust, variables have types that describe the kind of data they store. Rust is statically typed, meaning that the compiler must know the type of every variable at compile time. So it's very important. So types in Rust can be divided into scalar types, which are single values, and compound types, multiple values grouped together. So variable in Rust are immutable by default. This is also another different when you compare it with other languages. The variables are immutable. So what does it mean? You're going to see in action. So this is the best. You see here, this is a basic creation. We say, okay, function main, let x equal 5, and then print line. Let's actually do that. So we have let x equal 5. And then print line, the number is also the number is x. So where did I go? Oh, I forgot this because I forgot this. What's going on here? Oh, I'm used to code on Python and all that. So you have to understand that print. There's something wrong here. Print line. Why did I go wrong?
It's len, isn't it?
Oh yes, flip. Thank you. Thank you. So here it's basically printing. So here use the parentheses to that's where the variable will go that you've declared here. So the number is 5. That's what it's simply saying. So can you hear me like when I'm talking here? Because I don't know if I'm too. Can you hear me from this side? All right. So here the number is 5. So now let's say we want to. Now we say, okay, under this, we're going to write something else. let's say y equal 5. Sorry, not y equal 5. X equal 6. And then we print it. If you've programmed in our language, you'll assume that if I print it, then the x will become 6, right? But when I run it with on Rust, it says cannot assign twice to immutable variable. And it even gives you a suggestion. Because by default, it is immutable. So how do you now assign to the same? How do you make it more? How do you make this variable mutable? Then you have to type mute. So it's going to be let mute x equal 5. So when you put mute before a variable, then this variable can mutate. You can mutate it. So let me run it and you're going to see. So here you see it printed, the number is 5, and then it printed the number is 6. So now it's mutated, it took on a new value. Does it make sense so far? So this is here basic variable creation, and like I demonstrated, so let's x equal 5. If we change x equal 6 and then print it, it's not going to work. So this is good for blockchain, and it prevents accidental changes. When we need to change variables, you use mute to make variable changeable, like I showed you. For example, here it's showing. Let me make it larger. Like here, you say let mute x y equal 10. So when we declare a variable with a mute, then it becomes mutable, then it becomes changeable. So if I now type y equal 5 and print line, then it's going to print 15. This is the same, similar to what I showed you here. And now variable naming rules. So you can use latest, like these are variables. These are declare a variable. It starts with let. So like here, for example, let balance equal 500 rand. 500. So this is a variable, this is a variable, and this is a variable that is being declared. You can use letters, numbers. You can use underscores to separate words. For example, username, start with a letter, make it clear. But I wouldn't suggest you start with a number when you're naming variable. And shadowing. So you can reuse variable names. So here's the difference. Here, I showed you that you cannot mutate, right? When you declare a variable, it can't be changed. It's given an error, like cannot assign twice to the mutable variable. So what if now I'm asking you a question? What if I say let x equal 6? What's going to happen? What if I redeclare the variable? What's going to happen? What do you think is going to happen? Just one shot? Nope. So here you are basically, this is what we call shadowing. You are redeclaring the variable. So I declare a variable x equal 5. I can declare again a variable. So this is lost in memory. That 5 is lost. So it's like I've redeclared the variable itself. So this is called shadowing. It's a special Rust feature. This is different from mute. We're creating a new variable with the same name. Okay, what time is it? Okay. Data types. Like we spoke about data types. When you declare a variable, it has different data types. So why data types matter? If I say add 25 and 30, you know I mean 55. But if I say add 25 and 30, so these are words, the computer needs to know these are numbers, not text. So Rust type system. So Rust is strongly typed. Every value has a specific type. There's also type inference. Rust can often guess the type. And we can also specify types explicitly. Like for example, here the integer types, the whole numbers. We have I22, like let x I22 equal 10. So this is how you declare a variable. This is a signed integer of 32-bit. So 32-bit just means 2 to the power of 32 minus 1, which equal to, it's like 4 billion or something like that. So this just means that the range of I22 is between minus 2 billion 147 to 2 billion 147 and so on and so forth. So this just means that when you go to your calculator and then you type to the power of 2 to the power of 32 minus 1, you're going to have a number that is, you're going to get 4 billion point 2 plus, or 4 billion point 3 plus, excuse me. But here we're dealing with a signed integer, right? So there can be a minus, there can be a negative, there can also be a positive. So it just split in two. So it's like the total number of these values from minus 2 billion to 2 billion is 4.3 billion. I don't know if it makes sense. So that's where this 32 comes in. So you can put any value up to that number. So let me show you in action. Let me just quickly copy this. Oh my, let me see. So okay, this is quite simple. You're just going to print x is 10 and y is 25. So here what I want to show you is what if I put I8 let's see what it's going to show. So I8 is valid because it's 2 to the power of 8. So the number 10 is within that range of 2 to the power of 8 minus 1. I think the number is 256. So now, oh, it's not 256. It's 256 divided by 2, which is 125 or 26 something. So if I put a number like 150, it's going to give me an error because I'm out of range. So it's 128, sorry. So the range is between 128 minus 128 and 127. This is the I8. So if I declare a variable as an I8, the number that I put here has to be within this range here, because it's an 8-bit integer. And here, this is within range. The reason I'm not getting an error for U8, let me just put this in range. The reason I'm not getting an error for U8 is because U is unsigned. So there is no negative numbers under U8. So it's also 2 to the power of 8, but it starts from 0 and up. I don't know if it makes sense. From 0 and up. So there's no division between the negative side and then the positive. I don't know if it makes sense. Maybe I'm not so good at explaining that. So this is within range, but if I put a 6, then let's see, I think it's going to give me an error because the range is between 0 and 256. So when you are declaring a variable like an integer, especially when we're dealing with finance, we're dealing with numbers. If you're dealing with transactions of money and whatever, you have to make sure that I declare the right variable type. So the default variable type is I32. So here we just have to be within the range. So if I put 200, I'm not going to have any errors. So it's something that you have to consider when you're declaring a variable. So a simple explanation, I22 can be positive or negative. So the range is between minus 2 billion something to positive 2 billion and some change. So U8, it's only positive numbers. So they can also be U32. They can also be U64. So it's up to U64. So use I32 for most whole numbers. So floating point are just this, are like decimal numbers. So for example, here you see let x is equal to F32. So when the F32 is simply telling the compiler that this x is a decimal number, so which is 2.5. And then let y equal F64, which is also another decimal number. So I guess this is pretty much straightforward, right? I don't have to, it's just similar, it's similar to integer, whole numbers, but the only thing is the floating point, you're dealing with floating point. So now let's put something to the test. So here, everything works, right? So what if I say let x I32 equal 8.5? What's going to happen? What if I say let x I32 is equal to 8.5? I'd like to ask the beginner. Because I know if the beginner can get it right, then I know everyone understands. You can type if you want, if you're not comfortable. Or if you don't know, just say you don't know. No clue. Okay. Let me get back to it. Okay, so as I was saying, I22 deals with integers. So here we declare integer type or variable. And I think I went so far with telling you, like, talking about the bits, and I didn't have to talk about it. I think I went too far. So in simple term, when you declare a variable like x, for example, let x equal it's a variable. This part just tells the compiler that here, this variable is going to be an integer that is signed. So it can be a negative number or it can be a positive number. So, but here, floating point is used to declare numbers, decimal numbers, like 2.5 is a decimal number, 3.14 is a decimal number. So you use a floating point to declare decimal numbers. So to summarize, when we deal with whole numbers, you use I32 or U32. U is for the unsigned numbers, so numbers that don't have negative. So from 0 upward. I32 is when you declare a variable that could be a negative number. So this is so important because when you do calculations, you want to make sure that it is possible for your application to go negative. Like for example, if you're dealing with like in bank, like I've seen in my banking app, sometimes it write minus. Like I can be in the minus sometimes. So those programmers who created the banking app, they made it possible that it is indeed possible for the fund that shows on my banking app to be minus. That's an example. So now in this case, if I declare a variable as an integer, this is a signed integer, 32, and then I put 8.5, it's going to be an error because this is supposed to be a floating point. I'm supposed to declare a floating point this side. So it's going to be an error. So you can even see here, and I love Rust error, like it shows you. It shows you where the problem is. I32 expected I32 find floating point number. So here it expected a whole number, but I put a floating point number. So that's why I'm getting an error. So I guess this makes sense. And so we have floating point, and then we also have Boolean types. So Boolean types is just true or false. And we can use it for example, if it's raining, we can say let raining is equal true. If it's raining, or if true, do this. If false, do that. We're going to see that in action. Time is running out. I just want to get to the end of these today. So there is also character. So character is a type of can be something like an emoji, for example. An emoji is a character, like an emoji, maybe a heart emoji, that can be a character. Or even a letter, like a Z can also be a character. But you have to see that you use single quote. You have to use single quote, like it's the case here. Like for example, here we say let C character is equal to Z, let hot equal to whatever. So this is how it's used. And so this code will basically just print out the Z, and also is going to print out the hot. So I'll suggest that you also go through this code. I'm going to share this PDF today. You go through this code and then you test it out. You make some changes. Maybe you change, like for example, we can go here and let's say, okay, what if I change this to char, what's going to happen? Or if I change it to bool, what's going to happen? Or if I just go crazy and test everything, because that's how you're going to change. That's how you're going to learn. And what else? So yes, another important one is the tuple. So tuple, this is a compound type. So tuples are used for group of multiple values. And there's also another one also called a list, which is also a group type. I'm pretty sure arrays, some of you are familiar with coding. It also can also use it to list a number of elements in one place. So one thing, okay, let's just see it in action. Let's see in action. Okay. So here we have, oh my goodness. So this is also another thing that this is very important. Something that you also use is a tuple. So this is how it works. Here you can declare multiple variable in one compartment. You do it like this. You say let top is equal to, you can see this is I. The first value here is the I32. The second value here is F32, and the third value is U8. So there's a sign integer, which is 500. I can also put minus 500 because it's a signed integer. It's not going to give me an error. And then the second value that I put here is a floating point. So it can be 6.5 or whatever it is. And then I have U8, which is an unsigned integer. And I can put any number, provided it falls within the range. So now, this is how you extract the values. You let x, y, z is equal to top, and then you can print out these values like x, y, z. Remember, this is going to print out the values that you put here consecutively. Like it's going to print out the first x here. It's going to print out this one first, and then this one second, and then this one third. So it's just going to put this in place of this in place of that, and that in place of that. So if you say now, let's first tap 0, then it's just going to go to the first value here. So the first value is a 0. The second value here is a 1. And the third value here is a 2. So if I say, if I print out top.0, it's just going to print out this one first. So now let me confuse you a little bit based on what I've said so far. What if I change the y and then I put z here? What's going to happen? I mean, I put x. What if I put x? No. First, let me just print out. Let me see. Let me show you how it looks like. Okay, so if you look here, this is the first thing that we print out. We print out x 500, comma, y 6.5, comma, z 10. This is the first thing that we printed out. And then there's a second thing that we printed out here, which is first value 500, right? So what if now I just change the y and the z and the x, sorry. So what is going to happen? What if I exchange these two values? What's going to happen when I print out? Correct. Exactly, because it's printing out consecutively. So it's not just, I'm not printing these numbers like x, y. These are just text, right? The x here is just a text that I'm printing. It's not a variable, just a text, and this other is a text. The bracket, the curly bracket here, takes, so the first curly bracket takes the first thing that is the first variable, put it here. The y here will just take the x. So in this case, x is 500. So it's going to print out 500 here. And then the z, so z is going to stay the same position. So when I run here, it's going to print out exactly what we thought. So like I said, when you're coding, you're writing the instructions. So it doesn't matter if I put the wrong instruction, it's still going to run according to the instruction that I gave it. So this is what's happening. And based on what we've done, what if let me first let it back to the way it was. So what if I put 1 here, tap 1, what is it going to print out? Let first is equal to tap 1. Then if I run it, what it's first going to look like? I love the beginner to answer. Okay, so it's going to print out the first position of the tuple. So this is the 0th position, and this is the first, and this is the second. So it's going to print out tap.1. So it's 1, because remember it starts by 0, 1, 2. So that's what's going to happen. It's going to print out this place as expected, but it's going to here tap 1. So even though I put the wrong value, because this is not the first value, but it's going to print out the one that is on the position 1 according to this tuple. And another thing that we will deal a lot with is arrays. And here you keep the same type. It's not like tuple. Tuple, you can have different types. Like here, I have a signed integer, floating point 64, U8, and I can work with it together in one compartment. But here, I can only have the same type. So it either can be an integer, it either it's going to be strings or whatever it is. So it works similar like that one that we saw here. But here we just have to work with the same type of element. So here, the thing that happened here, because you can see here, I did not declare it as a I32. I did not declare it as a F32 in this place. And this is because there's what we talk about, there's inference that happened. We spoke about inference, the type inference. So Rust can often guess the type. So when we can also like declare a variable like this, like it happened here. We didn't even say the type. Rust is going to know that here you didn't for a whole number automatically. And the default is I32. So here, that's how you declare. This is your array. So your array has the length of 5. So this is the 0, and this is the first position, second, third, fourth. So if I want to print, if I say, okay, print the first element, then I have to go to the 0th element, which is A0. If I have to print out the second, then it's going to be A1, and the third A2, A3, A4. So it's worked very similar to this one. And yeah, we're gonna, so far, don't worry too much because we're going to see it in action. So now I just want you to to know the basic syntax in Rust and the data types. So we also have strings, and we also have these str. There are two different things, but you don't have to worry about it for now. So this is how you declare a string, variable, and this is how you declare an str. And okay, this is a simple example on how you can use it in action. You can declare a variable like a balance, for example, and then 100. An owner, you can declare a variable of an owner, and then you put the name as this is an str, and then you can also declare a boolean as true. So here, everything that happened here is inference. So Rust know that, okay, here you're dealing with a whole number i32. Here it's an str, and here this is a boolean. So this can happen automatically with inference. Okay, now we're going to the source, something that also very, when you compare with other programming language. So ownership is Rust's superpower for preventing bugs in financial software. So basic ownership rules: each value is exactly one owner. When the owner goes out of scope, the value is freed. You can transfer ownership or borrow temporarily. But we're going to see this in action. But this is just an example of how it works. You have a string and a hello string, S1. So now you say that let S2 equal S1. So you have declared a new variable S2. And then it's taking in S1. So when this happens, ownership has been moved from S1 to S2. So S1 now is gone. It's not going to work. Even if I try to print out S1, it's going to give me an error message because ownership has moved. I'm going to talk more about the implication of it, like why is this happening? So this is one of the things that happens, one of the differences between Rust when you compare Rust and other mainstream programming languages. And there's also borrowing data, references. This week, so if you want to avoid, maybe you want to use the same data here, like for example here, I want to take the value in this string and declare a new variable that use the same value in S1, but I don't want to lose S1. I don't want to change ownership. To do that, you borrow. And this is how you borrow. You declare your variable, your string. In this case, you declare a string. And instead of saying S2 is equal to S1, you put that end operand, whatever we call it here, and in this case, you are borrowing the same value that is here is going to be here. So now both this and that is going to work. So when you're printing out this and that, it's going to work. Yes, this is something that you can also go through at home. So use Rust Playground to play with this. Let me share this in a comment. Okay, so you can play with that. I'll also share it in the resources. So yeah, this is a brief introduction in Rust. So next week, we're going to get our hands dirty. And I'd want you to also install this. So if you have development background, it's going to be easy for you to follow, to install all these. But if you run into problems, you can contact me during the week. I'm usually free in the evening. So if you run into problem when you are setting it up, you tell me. But I'm going to send you some resources that shows you how to install all this. And another thing, is there anything I have to add? Any questions? Today you were quiet.
No, it was a good session, eh? I was just wondering if you could share the Google Drive link.
Yes, let me do it now, and I'm also going to share it in the group.
No, it was pretty good, eh? Like it was interesting and confusing, and it's basically
Sorry, I lost you.
like mutable is let
Sorry,
kind of language. So it's kind of similar
I lost
in a
you.
lot of ways. So I'm just saying, kind of interesting how they define what you're doing. So it's kind of like you declaring a constant, which is always constant, can never change. And then we're using mute. It becomes like more like let. You know what I mean? Like Java,
Yeah.
or like, and then I can see the C as well. So it's pretty interesting, like seeing what's going on and like how it sort of works and is supposed to work. So it'll be cool to learn this thing.
Yeah, it's a cool language.
Yeah.
Any other question?
I was just curious about one other thing though. Like I was reading up about COBOL today. So is it similar in structure to the older school
I have no idea.
languages, or can you hear me?
I'm a new age. I don't know about the old programming languages, so I'm the wrong person to ask.
Okay, cool, fair enough.
COBOL. But have you coded in COBOL before?
No, I was chatting to someone in fintech.
Okay.
And we were just discussing banking and some other stuff. So we were going over a few things. And then I was looking at Rust and Cobalt and comparing them just to see what's different. And like a lot of things are kind of similar and kind of different. So that's interesting.
Yeah, I think it's more comparable with C. Because C also is kind of like lower level compared to programming language like Java and Python.
Yeah, it's microprocessor. So it's evil. It's close to the machine, bro. Too close. But this is cool.
So any other question? There's something I want to say, but I think it's something I wanted to add. Yes. I'm going to send you some question, like an assignment. Not because I want to grade you or anything, just for reinforcement, to help you reinforce what you learned so far. So it's going to be based on the previous slides that we did, those 3 slides. So yeah, just to help you, because you might have some gaps in some understanding. So when you go through it, when you try to answer those questions, then you'll try not to remember, and it's going to reinforce your learning. So I'm going to send it to you tomorrow, and you can do it over the weekend. All right? Yes, Mohammed?
Hi, Ben. Thank you for the session. You said there is group, or because I'm not in this group, or how to contact you?
Are you on Telegram? Do you have Telegram?
Yes.
Okay, let me share the Telegram. So yes, I'm going to drop.
Thank you.
I'm going to drop the assignment on Telegram, on WhatsApp, and on what do you call it, on Discord. Okay, that's it for tonight. And please go through what we did today. Please go through it on your free time and play around with it. And that's how you're going to learn. If you don't understand, ask ChatGPT to break it down in a way that you can understand, or maybe as a 5-year-old, for example. And and also try out new things, and you can even go beyond this scope if you want, because the aim of this is just to guide you into becoming a smart contract dev in Stellar. Anyway, thank you for being here tonight. I appreciate you guys, and see you next week.
Cool. Cheers, guys. Thanks, Ben.
Thank you.